Today we're solving polynomial inequalities. What is a polynomial inequality? Let's have a look. All right, so this is a polynomial inequality. All right, so we're asked to solve the following inequalities. So polynomial inequality is just that. It's an inequality, but it involves a polynomial. Okay. So we're asked to solve. So what does this mean? This means we need to find all the x values that satisfy this inequality. So we need to find all the x values such that when we plug it into 5x squared plus 13x plus 6, we get a value that's less than or equal to 0. So what's the first step here? First step is we want to factor this left-hand side. So let's see if we can do this. All right. And we're going to continue maintaining the less than or equal to 0 throughout. Okay, so we know we need x's in the first component. What are the factors of 6? Factors of 6, let's go with 3 and 2, see if that helps. Factors of 5 are just 1 and 5. So now we need to put the 5 in the appropriate place. Well, let's see. If we put 5 here, then we have 15, and then we need to get a positive 13 here. We can put a negative there. However, the 3 and the negative 2 give us negative 6, not positive 6. So this is probably not the correct factorization. So let's try again. Okay. What if we put the 5 here? Then we have 5x times 2 is 10x. Well, first we have 5x times x. And we get 5x squared. 5x times 2 is 10x. Plus 3x, that's 13x. And 3 times 2 is 6, and plus 6. So this factorization works. So good. We've got a factorization that works. And next, let's determine what x values satisfy this inequality. First, we're going to consider when the equality. So when is it equal, or when does 5x plus 3 times x plus 2 equal 0? So let's solve. That occurs when 5x plus 3 equals 0 or x plus 2 equals 0. This occurs when x equals negative 3 over 5 or when x equals negative 2. So we're going to use these two values to divide our real numbers into intervals. Okay, so we have negative 2, negative 3 over 5. So we, let's see, why don't we rewrite this over to the right-hand side, and then we can work with our intervals and our factors. Okay, let's just rewrite this over here. So we're going to we're going to break up a real line into intervals. Okay, let's put our values, negative 2 and negative 3 over 5, on our real line. And now we have our intervals, x less than or equal to negative 2, x between negative 2 and less than or equal to negative 3 over 5, and x greater than negative 3 over 5. So these are our 3 intervals. Our factors are 5x plus 3 and x minus, I think x plus 2, I believe. Let's check. Oops. Yes, x plus 2. And then, of course, we have our function, or the product of the two. 5x plus 3 times x plus 2. Good. So now let's look and see what happens to each of these factors on these intervals. All right, so when x is less than negative 2, 5x plus 3 is a negative value. When x is between negative 2 and negative 3 over 5, 5x plus 3 is again a negative value. Finally, when x is greater than -3/5, 5x plus 3 is a positive value. Put a plus sign there. And then for x plus 2, we have negative, positive, and positive. Okay, so now let's look at our product or function. 5x plus 3 times x plus 2. If we look down the columns, we get the product of two negatives is a positive. Product of a negative and a positive is a negative. A product of two positives is a positive. Good. So now our original problem was when 5x plus 3 times 5x plus 2 was less than or equal to 0. So when does that occur? That occurs on this middle interval right here. It occurs when x is greater than or equal to -2 and less than or equal to -3/5. So we include the equalities because our original inequality includes the equality as well. All right, good. So let's look. I think we have one more. We have two more. All right, so next one. We have x to the power 4 minus 1 is greater than or equal to 0. So again, we're going to start by factoring. So this is a difference of squares. So x squared minus 1 times x squared plus 1. X squared minus 1 is again a difference of squares. X squared plus 1 cannot be factored, so we just leave it as is. So now we have the factorization x minus 1 times x plus 1 times x squared plus 1. When does this left-hand side equal 0? When x equals 1 or -1. And again, let's scroll over to the right where we have a bit more space. We can use these values to divide our real line into intervals. In particular, when x is less than or equal to -1, x is between -1 and 1, and x is greater than 1. Our factors are x minus 1, x plus 1, and x squared plus 1. And our final function is x to the power 4 minus 1. Okay, so let's see what happens on these intervals. Right, so x minus 1 is negative when x is less than -1, negative when x is between -1 and 1, and positive when x is greater than 1. X plus 1 is negative when x is less than 1, positive when x is between -1 and 1, and positive when x is greater than 1. And x squared plus 1 is always positive. Our function is positive when x is less than -1, negative when x is between -1 and 1, and positive when x is greater than or equal to 1. So what was our original inequality? X to the power 4 minus 1 greater than or equal to 0, and that occurs when x is less than -1 or x is greater than or equal to 1. And again, we include the equality in both cases for both intervals because our original inequality included the equality as well. All right, so looks like we have one more. We have quite a few here today. Okay, so our function is x squared minus 5x plus 6 times x cubed minus 1. All right, so we need to determine when this is less than or equal to 0. Again, let's factor. Okay. All right, so x squared minus 5x plus 6. That's a quadratic. So we have two factors. Factors of 6 are 3 and 2. 3 and 2, and we want Those factors add up to -5 and multiply to +6. So we'll put negatives in front of both of them. X cubed minus 1 is a difference of cubes, so that also factors quite nicely. So x minus 1 is one factor, and the other factor is x squared plus x plus 1, which unfortunately doesn't factor. So therefore, our zeros, or roots, are x equals 3, 2, and 1. Okay. So these, when we plug in the values, x equals 3, 2, or 1, the left-hand side is going to equal 0. So that takes care of the equality. Now we need to consider the intervals for the inequality. Okay, let's move over to the right again. And with those values, we can divide up our real line into intervals. So let's do that. Okay. Our first interval is when x is less than 1. Our second interval is when x is between 1 and 2. Third interval when x is between 2 and 3. And fourth interval when x is greater than or equal to 3. Let's put our factors in: x minus 3, x minus 2, x minus 1, and finally x squared plus x plus 1. And of course, the product of all of these is x squared minus 5x plus 6 times x cubed minus 1. All right. Okay, so let's see what happens on each of these intervals for each of the factors. X minus 3 is less than 0, is negative when x is less than or equal to 1. Negative when x is between 1 and 2. Negative when x is between 2 and 3, and positive when x is greater than 3. X minus 2 is negative when x is less than 1, negative when x is less than 2, positive when x is between 2 and 3, positive when x is greater than 3. X minus 1 is negative when x is less than 1, positive when x is between 1 and 2, positive, and then positive throughout. And finally, x squared plus x plus 1 is positive on every interval. Yes, it's positive on every interval because the x squared is is always going to be much larger, even if we have negative values for x. So now, if we look down the columns, when x is less than or equal to 1, our product is negative, because we have the product of 3 negatives. When x is between 1 and 2, we have the product of 2 negatives. So we have a positive value. When x is between 2 and 3, we have 1 negative, so we end up with a negative value. And finally, when x is greater than 3, we get a positive value. So our original function, what were we looking for in our original inequality, was x squared minus 5x plus 6 times x cubed minus 1 is less than or equal to 0. So which intervals does this occur? So this takes place, so therefore when x is less than or equal to 1, or when x is between 2 and 3. So there's another way to write this, which we didn't do earlier in the previous examples. You can also write this as the set of x values that are part of the real numbers, such that x is less than or equal to 1, or x is greater than or equal to 2, or less than or equal to 3. Good. That brings us to the end of our video today. So if you have any questions, send us a note at info@raisemymarks.com or give us a call day or evening. We'll be happy to answer your questions. Thank you for watching. We look forward to seeing you again.